Hey, this is data mining and warehousing. We are moving into week 12 and 13. We're talking about data warehousing and OLAP. This is chapter 4. So, what are we going to cover in this chapter about data warehousing and online analytical processing, or OLAP? We're going to talk about warehouse basic concepts, data warehousing modeling. We're going to talk about the data cube and what's OLAP. We're going to talk about data warehouse design and usage, data warehouse implementation, data generation by attribute-oriented induction, and summary. So for today, we're going to talk about the basic concepts. What is a data warehouse? There are many definitions for data warehouse. Um, in general, not very rigorously. This is a decision support database that is maintained, means that it is separate from the operational databases of the organization. And the reason for having a data warehouse is to support um, information processing, because we have a platform where all historical data is combined and ready for analysis. The official or the more rigorous definition of a data warehouse is that it is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decision-making process. So the purpose of having a data warehouse is to support decision-making of the management. And what kind of data does warehouse contain? It is subject-oriented, it is integrated, it is time variant, and it's non-volatile. We're going to talk about each one of them. Now, data warehousing is the process of constructing a data warehouse. So a data warehouse is where we keep a huge amount of data that is relevant to a certain organization in order to use it for decision support or support making decisions. And the process of creating such a construct is called data warehousing. Now, data warehousing is subject oriented. What does that mean? It means that it is organized based on major subjects. So the way that the data warehouse is organized is based on the major subjects in the organization. So, for instance, an organization where there are sales, there's products that are sold, and there are customers, um, uh, then the data will be arranged based on that, based on the major subjects in the organization. This means that we are focusing on modeling and analysis of data for decision making. So we want to make decisions about, let's say, future sales, about our products, about supporting our customers. Therefore, the way we consolidate data, the way we construct data is around them. It's not around, uh, you know, um, a certain transaction that happened a certain day. Um, the data warehouse will provide a simple and concise view. Simple, it means that it's not complicated, and concise means that it is summarized view around particular subject issues. So we are actually trying to focus about only customers or only sales or only products without looking at the other subjects. So we provide a simple and concise view around these subjects. How? By excluding data that are not useful in the decision support process. So we remove any kind of data that are not useful for decision making. Now, a data warehouse is subject oriented because it's actually, instead of having transactional data, it's process oriented, meaning that each entry in a transactional storage will consist of various aspects about this entry, about a certain sale happened. So this is the sales representative who conducted the sale, the quantity that was sold, the part number that was sold, when was it sold, what's the customer name, what's the product description, how much, and the mail address. So these are information about the sale that took place. Now, when we want to move this information to the data warehouse, and it's actually subject oriented, we will be collecting the data based on the subject. So data about the sale will be moved here. Data about the customer, this is queued a bit. So data about the customer name and the mail address will be here, and the data about the products will be the part name, the product description, and the unit price will be moved in a separate place. Now, the data warehouse is integrated, meaning that it's actually constructed by integrating, which means combining multiple heterogeneous data sources. Heterogeneous means different. This means that we obtain data from all sorts of storage. It can be in a relational database. It can be just flat files. It can be Word documents. It can be online transaction records. It can be objects. It can be whatever kind of um, representation, data representation, and all of these are combined together. They are heterogeneous, they are different, but they are combined, they are integrated, and they are be represented using the data warehousing representation. Now, for to be able to do that integration, we need to apply data cleaning. So data cleaning and data integration techniques are applied. This means that we want to make sure that we are consistent in naming conventions because we are combining data from different data sources, from different databases. We need to make sure that we are or we have consistent naming. Encoding structures. How do we encode data? For example, if we are encoding, let's say, area codes, do we add the plus or we don't add the plus? For instance, do we use the country name or we just use the number, for example, the area code? Also, what kind of attribute measures used? Do we use the weight in kilos or in pounds, for instance? And all of these data cleaning and integration techniques are expected to have or to move the data, to convert the data into a form that is shown to be consistent, although it is coming from heterogeneous data sources. Okay. Now, data warehouse is also time variant, meaning that it does not represent time. So the time horizon for the data is actually the time, let's say the time span or the time zone or the time period that the data covered or the data included in the data warehouse is way bigger compared to operational databases. Meaning that operational database will have the current values of data, the daily, let's say for this year or probably for 3 years ago. However, in the data warehouse, it provides consolidated data from 5 to 10 years ago. Every key structure in the data warehouse will contain an element of time, either explicitly or implicitly. It means that every information that we have will tell us when did we obtain this data. But the key operational data may or may not contain time elements. Even if the operational data does not have a timestamp, the data, once loaded into the data warehouse, will or is expected to include a time element, such as the time of loading. Now, a data warehouse is also non-volatile, meaning that it's actually a physically separate store of data transformed from operational environment. It means that when we update the data warehouse, it doesn't happen frequently. It's not always on the go. It's not always being updated. Not as in the case in the operational data. So in operational data, we're always updating. We're searching, we're updating, we're deleting, we're editing. So in the case of operational data, updates are frequent. However, in data warehousing, it doesn't happen or doesn't go that frequently. Now, operational update of data does not occur in the data warehouse environment. So if you want to update the operational data, you do not update it in the warehouse. You update it in the operational data. So it does not require transaction processing, recovery, and concurrency control mechanism because we are not accessing the data warehouse frequently. So what does this mean? It says that data warehouse does not require transaction processing or recovery or concurrency control because there is no frequent updates over the data warehouse. There is no frequent access of data. There is no expected problems of concurrent access of data. However, it requires only, this is the data warehouse, it requires only two operations: initial loading of data and access of data. Initial loading of a chunk of data, and then the access of data, which means the access of the results that uh, come from the data. So when we say that the data warehouse is non-volatile, this is the transactional storage or operational storage, and it actually allows for record by record manipulation. You can change, for example, if a certain sale, you want to change the sale rep who was responsible of doing the sale, or you want to insert a new sale that happened that day, or you want to delete a sale that did not get through. Okay, so it's always happening, change is always happening. In the case of a data warehouse storage, we only have mass load, okay, huge amount of data that's loaded to the data warehouse and it doesn't get changed. And then we get access for information processed within the data warehouse. Now let's compare between online transactional processing. The users are IT professionals or clerk, someone who accesses the data. The function of online transaction processing is to day-to-day operations. The database design, it's based on the application. The kind of data is current, up-to-date, detailed, relational, isolated. It's flat, relational, isolated. Usage, we use it repetitively. We always use it. We access it for reading and writing, index, hash, or prime key. Unit of work, short, simple transactions. So we want to store a simple transaction. Number of records accessed, tens of records accessed. Users can be thousands, all accessing the OLTP. The database size can be from 100 mega to gigabytes. And metric transaction throughput. The OLAP is actually the users are the knowledge workers. It is used for decision support. It's subject oriented, just as we explained. The data is historical, summarized, multidimensional, integrated, consolidated, very clear. The usage of OLAP is ad hoc. It means that as needed. And the access is done for lots of scans in order to retrieve results of analysis of data. Unit of work, complex query. So we'll be formulating a complex query in order to retrieve information. And number of records accessed, millions. Users can be hundreds, so less users accessing OLAP. A huge database size, and the metric query throughput or response. So transaction throughput here means the time needed for transaction to get processed, and query throughput is the time of a query gets processed. why a separate data warehouse? Why do we need to separate data in a separate data warehouse? First of all, we will have um, high performance for the data warehouse, but we also want to make sure that the DBMS, which is the operational data, which is tuned for the OLTP, that will also have high performance. So DBMS tuned for all the OLTP, access methods, indexing, concurrency control, and recovery. These are what actually make a DBMS have perform well. So we will improve on access methods, we will have indexing, we will have concurrency control and recovery in case of problems. Warehouse, however, which is tuned for OLAP, in order for it to perform well, it needs to be able to run complex queries, and it's also need to have a multidimensional view and the ability to consolidate data from different sources. So we need to have high performance from both systems. However, what's expected from each system is different, therefore we separate them. Also, we have different functions for the operational database, and which is different from what we need from the data warehouse, and also the type of data that we need is different. So we need to make sure that missing data, which in order to support decision support, requires historical data, which operational DBs do not typically maintain. So operational DBs does not contain the type of data the way that the warehouse does. This means that these are missing data. These are data that we need for decision support, but we cannot find them in the DBMS. Also, data consolidation, which means combining or aggregating. Decision support requires that data is aggregated, summarized, and this needs to be done from heterogeneous data sources, means different data sources. However, the standard DBMS does not allow for that. Also, data quality, having different sources typically use inconsistent data representation, codes, and formats, which have to be reconciled. So in a data warehouse, we actually have mechanisms to deal with data quality issues. And in the DBMS, we actually do not focus much on that. Now, there are more and more systems which perform OLAP analysis directly on relational databases. So it's not entirely the practice that data warehouse is 100% separated from a DBMS or an operational system. However, the bigger the organization, the more it needs to have its data separated in a data warehouse. And we actually have a data warehouse here at the university. Now, a data warehouse is actually a multi-tiered architecture, meaning that it consists of tiers, or you remember three tiers architecture, two-tier architecture. This is a multi-tier architecture. So first of all, we have the data sources, operational data sources, and other data sources, just as we gave examples earlier. And then we have the data storage, where the data from these data sources are extracted, transformed, loaded, and refreshed into the data warehouse, which contains metadata. It also produces data marts, and we're going to explain what are these. And also metadata and monitor integrator, they all assist in loading the data into the data warehouse. And then we have the OLAP engine, where it uses an OLAP server in order to serve or order to provide analysis, query, reports, or also provide data mining. Okay, and these are the front end tools. These are the tools that the users interact with. So What are the three models of a data warehouse? We have an enterprise warehouse, we have a data mart, and we have a virtual warehouse. An enterprise warehouse collects all of the information about subjects spanning the entire organization. This is what we gave an example for so far. We have also a data mart, and a data mart is a subset of corporate-wide data that is of value to a specific group of users. It means that it is a small, so instead of a data warehouse, it is a small part of the data warehouse, but it is containing that data that a specific group will be interested in. So, for example, a data mart for marketing data or a data mart for sales data. Now, these data marts are actually directly coming from the warehouse. So they are actually independent because these groups access them directly without the need to go through the data warehouse. However, they are also dependent because they get their data from the data warehouse. So they are independent and dependent at the same time. Another model of a warehouse is virtual warehouse, which is actually a set of views over operational databases. Okay, and it allows only some of the possible summary views. So it's actually something that is mimicking a data warehouse. It's not actually the same as a data warehouse. Uh, it's what do you call it? It's actually doing something uh, uh, part of the analytical services that the data warehouse provide, but it is not does not have the full functionality of a data warehouse. Okay, I'll stop here for the first part of the lecture, and then we will continue from here.